is physics, one of the big applications of calculus you see in physics. How things move, why they stop, why they don't stop, things like that, all right? Motion, right? Physics is all about motion, things moving, okay? So we have terms. There's different terms for different things when we're talking about motion. The first one is position. Where am I at? Where's your position at, right? Where are you located, right? That's position. Its derivative, so position's first derivative, is velocity. Velocity is a rate, right? It could be miles per hour. It could be feet per second. It's a rate, okay? Because it's a first derivative, right? Rates are slopes. Slopes are the same thing as rates. So the first derivative of position is velocity. So sometimes they'll call position x of t, sometimes they call it s of t, they never call it p of t. I don't know why they don't use p. It must be something different, but for velocity, they'll call it position's first derivative, or they'll call it v of t for velocity, okay? And then velocity's first derivative is acceleration, also a rate, but acceleration is a rate of a rate. Okay, so what does that mean? Think of your car. Think of your car. So the number, so when you're driving in your car and it says 30 miles an hour, 34, 35 miles an hour, 40 miles an hour, if you're on the highway, it goes even faster, right? That is a velocity, right? 60 miles an hour means 60 miles for every hour you're driving that fast, right? Mm-hmm. That's velocity. We call it speed, okay? That's a rate over, that's a miles per hour, right? What is acceleration then? Acceleration is how fast is that number changing? If I'm in my car and it says 60 and it doesn't change from 60, I'm moving, right? But my acceleration isn't moving because I'm not picking up speed or slowing down, right? So you can have negative acceleration, you're slowing down. Or you can have positive acceleration, you're speeding up. So that's the difference between acceleration and velocity. Velocity is how fast are you moving? Okay, how fast is something moving? Acceleration is how fast is it picking up speed or slowing down, right? So when you get on the highway, that's when you accelerate, right? That's why the gas pedal is sometimes called the accelerator. You're accelerating because you're going faster to get on the highway to speed up with everyone else, right? So they're all related. So what they're going to do is this chapter, they're going to give you position, and they'll ask you questions about velocity, or they'll ask you questions about acceleration. Or they'll give you velocity, and they'll ask you questions about acceleration. Mm-hmm. Or they'll give you acceleration. They'll never go up. They'll never go up. So they'll never give you acceleration and then want you they'll ask you questions about velocity or position. They will, but not this chapter. Not this chapter. Next, that's to go up the scale. Well, how do we go down the scale?
Wait a minute.
So how do I go from derivatives, right? How do I go the other way? That's integration. That's integration. Okay? So next semester, don't worry, we'll come back to this. But for this chapter, we're only either, so if they give you position, they're only going to ask you about position or anything below, velocity or acceleration. They're only going to ask you that level or below. Okay. They won't ask you to go up the scale. Okay? Yeah, till next semester. Next semester, then you'll figure out how to do it. But for right now, don't worry about it. So position, you're going to see those words a lot. Position, velocity, acceleration. Okay, you're going to see them a lot. They're all related. Okay? So there's a lot of bullet points here because a lot of them we've talked about before, but they're just, we don't say first derivative, second derivative, first derivative test, second derivative test. We use things like velocity, acceleration. Okay? So a lot of it you know already, but they're just different terms. Okay? Average rate of change. We've done average rate of change, right? Mean value theorem, we have to find on average, how fast was I going from point A to point B? That's average rate of change, right? Instantaneous means derivative at one point. Derivative at one point. Find the derivative, plug in the value. That gives you the derivative at one point, right? We knew those two. And then we just said the derivative of position is velocity. The derivative of velocity is acceleration. Speed and velocity. So how come when I'm driving my car and I'm going 40 miles per hour, we don't call that velocity, we call that speed? Why?
Because you can go backwards also.
Because you can have negative velocity. You can have negative velocity, but I can't have negative 40 miles an hour in my car, right? You can't possibly go negative 40 miles an hour. So when we're talking about speed, it's always positive.
Yeah.
So speed and velocity can be the same thing if they're both positive, right?
Yep.
But if it's negative velocity, how do we have negative velocity? We have it. We'll talk about that later. But it's direction.
Yeah.
So if you're going in the positive direction, you're going to have positive velocity, right? Positive numbers. If you're going in the negative direction, you're going to have negative velocity. That's how you can have negative. Direction matters. But in my car, it doesn't matter if I'm going north, south, east, west.
Yep.
It's just all positive, right? Even if you go back, even if you're backing up from your driveway, it's not negative, right?
You still wasted. You still spent the gas.
Okay, yeah. So it still says, when you're backing up, it still says 1, 2, 3 miles an hour, however fast you back up, right? So that's why in our cars, we only see positive. We talk about speed. In physics, we talk about velocity a lot. That's the differences, okay? Displacement, how far you are from where you started. So straight line distance, right? So like from East Campus, if I had a string that go from here all the way to East Campus, it would be one straight line. That's displacement, right? If I start here, end up at East, one straight line measures that distance. That's my displacement, right? But let's say I got in my car, drove to East, drove back. What's my displacement? 0. Okay, 0.
Back where you started.
Distance is total distance traveled. So you would add up, okay, how far did I drive that way? How far did I drive back? It'd be a grand total. Okay, so that's the difference between displacement and distance. Displacement is just how far am I from where I started, right? If I take 2 steps forward and then I take 2 steps back, displacement is 0, but distance is 4 steps, okay? When a particle is at rest, so when something is at rest, it's not moving, its velocity is 0. That's how we know. So they're going to ask you this. They're going to say, when is the particle at rest? You're like, what? That means when velocity is 0. Okay? Okay. Velocity is increasing. So when are we picking up speed? When is velocity getting bigger and bigger? When acceleration is positive. So if I have a positive acceleration, think of you're stepping on the gas pedal, right? And decreasing, and when you're decreasing is when acceleration is negative. Okay? Increasing, acceleration positive, decreasing, acceleration negative. Speed, when is my speed getting increasing? When acceleration and velocity have the same sign. Okay? Moving in the same direction, positive or negative. Decreasing is when they have the opposite signs. Okay?
Oh, so that's like when you're going like 30, but you're slowing down. Like when you're pressing the brake.
Exactly. Average acceleration of an object is the total change in velocity divided by the total change in time. That's, it's kind of like average rate of change, but for acceleration. Okay? It can be thought of as the slope of the line connecting 2 points on a velocity function because it's the derivative of the derivative, second derivative. Okay, so they're going to ask you questions about when is velocity positive, when is velocity negative, or when is velocity positive and acceleration negative. Well, this is what it means. This is kind of a cheat sheet of what it means. Okay? So when am I slowing down? I'm slowing down when velocity is positive, acceleration is negative. Or when velocity is negative and acceleration is positive. When am I speeding up? Opposite, right? Same sign. Constant velocity to the right. That means you're moving to the right. You're moving to the right. Think of a number line. When you're moving to the right, it's positive velocity. When you're moving to the left, it's a negative velocity. Okay? When acceleration and velocity are both 0, that means you're stopped. You're not moving. Okay? You're not moving. Okay? So you're going to see moving along a line. That's think of a number line. If I'm moving to the right, it's positive. If I'm moving to the left, it's negative. Velocity, I should say. What is velocity assume? Okay. So yeah, that's what this says down here. Okay. Something moves to the right. So that's the difference between velocity and speed. Speed, direction doesn't matter. Doesn't matter where you go. It's always positive. Velocity, direction does matter. Okay. All right. So now let's look at example number 1.
Acceleration.
So you're going to see a lot a particle or an object, right, moves along the x-axis. That means it's moving left and right. It can only go left and right. Left is positive, left is negative, right is positive. Okay, so a particle is moving. Time starts at 0 and it gets bigger, right? We can't go negative time, so time always starts at 0 and it never stops. Its position is given by the function here. So they gave us position, right? How do we determine acceleration at time 7? What do we have to do? Find the second derivative, right? Position and acceleration. Acceleration is the second derivative, okay? So the first derivative is velocity. V of t, or you can use x prime. It can be x prime of t, or you can use v of t. Either one's okay because they mean the same thing. So the first derivative is 3t squared minus 22t minus 16. That's velocity. They didn't ask us about velocity. They asked us about acceleration. So acceleration is v prime of t. It's got a lot. Acceleration has the most amount of names. It's x double prime of t, or v. Do you have to write all the names? No, I'm just doing it because it's the first question. You don't have to write all of these. You just have to pick one. But the reason I'm doing all of them is just to show you that velocity has 2 names, acceleration has 3 names, position only has 1 name, okay? Acceleration. So find the derivative again. 6t minus 22. T is 7, right? Plug in 7 for t. Uh, 20. Now, it is a rate, but they don't tell us units. So if they don't tell us units, you don't have to write the rate.
Okay.
That's a great question. That's a great question, though, to ask. So position is just distance, miles, meters, inches, right? Velocity is measurement, is distance over time, miles per hour, miles per second, feet per second, centimeters per second, those types of things. What is acceleration? Acceleration is distance over time squared. So feet per second squared, miles per hour squared, that's acceleration. So if they ever ask you for those, that's you would use acceleration. Okay? All right. Okay, number 2. Particle moves along the x-axis so that when time is positive, its position is given by x of t. Determine all the values of t when the particle is at rest. So let's go back to our first page because no one memorized this.
Oh, I did.
You did. You know when particle's at rest. When is particle at rest?
When velocity is 0.
There you go. There we go. When velocity is 0, that's when a particle is at rest. Okay? So do we have velocity?
No.
Nope. Let's get velocity then. How do I get velocity using position? Derivative, right? First derivative. 3t squared plus 12t minus 36. So when that is equal to 0. So it's a quadratic, so we're going to get 2 answers. So you can divide all by 3. oops, minus 9. So what are the, minus 12, yeah. Wait, no, but I divided by 3.
Yeah, 3. 36 divided by 3 is
Oh,
I did the same thing.
thank you. Okay, what are the two numbers that multiply to be negative 12 and add to be 4? 6 and negative 2. Negative 6, or sorry, positive 6, negative 2. So we get two answers. We get negative 6 and positive 2. If you were to put both of those answers, you would get it wrong. Why? So if I was to put both of those answers, this is, okay.
Because time is not
Yeah, time can't be negative.
So it's only 2.
So it's only 2. So this guy, just put an X through it. Because remember, anything with an X through or a line through, you can't read. Reader can't read. It's not allowed to.
Okay,
So the only time is when time is 2. So when time is 2, the object, the particle, whatever it is, won't be moving.
So even when you find them all, you just have to check if they're negative.
Yeah, time can never be negative.
I'm back.
Can velocity be negative? Yes. Can acceleration be negative? Yes. Can position be negative? No. Oh, wait, yes, it can. It can, because if it's on the number line, it can be in the negatives. Yeah. Position can be.
Just can't.
Okay, next one.
Mobius strip. Mobius.
A particle moves along the x-axis so that time is positive. That little statement there will be like on every single problem you see, or almost every single problem. It's pretty obvious, but they always include it. Its position is given by x of t, so they've given us position again. They want us to know when the object particle is moving left or moving right. So when do we know when something is moving to the left or moving to the right?
Right is positive, left is negative.
There you go. Yep.
Well, time to
You look, if you didn't know, it's right here on the first slide. So most of the questions you have will be on the first page. If you don't remember them, that's why I put it there. Okay? So when the object moves to the left, that means velocity is negative. When an object moves to the right, that means velocity is positive. So really what we're doing is first derivative test. That's all we're doing here. Okay? First derivative test is all we're doing. Where is the velocity positive? Where is velocity negative? Okay? Okay, so we need velocity first. Negative 2t minus 8. So what do we do next? When we had the first derivative test, before we got to the number line, what did we do after we found the first derivative? Done. How do we find the critical values? Yeah.
0.
Set the first derivative equal to 0. Good. So most of everything we do today is going to be stuff we've done before. They just have new names. Instead of saying, where is the function increasing and decreasing, it's saying, where does the particle move left and right? But it's the same thing. So add 8 to both sides, divide by negative 2. Wait, did I do that? Let's see. Wait, what did I do? Did I do something wrong here?
I thought we got it because it's at 5.
Negative 2.
Why you put it 5?
Oh, sorry. Yeah, I don't need to do the test because I'm just checking 5. Yeah, sorry, I'm just checking 5. Sorry, took a little detour. So I'm going to plug in 5. Negative 10 minus 8 is negative 18. So how does that help answer my question?
It's negative.
It's going to be negative. It's going to be negative. So how does that answer my question? Didn't ask me if it's positive or negative. What did it ask me?
It was moving right or left.
If it was moving right or left. So a negative velocity means it's moving to the left. Moving to the left. So we would say at t equals 5, the particle is moving to the left. Okay, and then you would say v of 5 equals negative 18.
Said he-
Okay. Where is it? All right. No. Okay, next one. Example 4. A particle moves along the x-axis so that at time 0, time is greater than or equal to 0, its position is given by x of t. Determine all intervals, so now they want intervals, when the speed of the particle is increasing. So when is speed increasing? When is speed increasing?
Acceleration and velocity are the same.
When acceleration and velocity have the
Two signs.
I'm saying but different.
It might need to be separated.
When is speed increasing? Speed increasing when acceleration and velocity have the same sign. When acceleration and velocity have the same sign. All right, so let's write that down. Let's see. So v of t and a of t have the same sign. Okay, so in order for us to find that, we have to figure out what v of t and a of t are. Okay, so first v of t. V of t is 4t cubed minus 36t squared. I should put v of t. Okay. So how do we use that to figure out when velocity is positive or negative? Find where it's 0 first, right? That's first derivative test. Now we're doing first derivative test. Okay? So figure out when it's 0. So you can factor out, you could divide both 4t squared, which will leave t minus 9.
And 0. So we find v and 9.
So 4t squared equals 0, and t minus 9 equals 0. So this is just going to be where t equals 0. Add 9 to both sides. So it's going to be where t equals 0 and t equals 9.
What'd you do?
She thought it was subtracting the 4.
For a second, yeah, for a second.
Okay. All right, so let's do first derivative test.
Here's what he meant with first derivative.
So actually, we don't need to go left and right because it's time, right? So we don't need an arrow there. We can just use a segment. It's more of a ray than a line.
We can only use 0.
All right.
I don't think one works.
Okay. So plug in numbers in between. That's the nice thing about time is because it only can be positive. So you don't have to worry about any negatives. So pick a number between 0 and 9, pick a number bigger than 9, into the first derivative, is it positive or negative? Well, let's see. Pick whatever number you want. I'm going to choose 1. I'm going to pick 1. So if I plug in 1 to the first derivative, you can plug it in here, plug it in here, or plug it in here. They're all the first derivative, whichever one's easier for you. So if I plug it in, I'm going to get a positive times a negative, which is a negative. After 9, so 10, when I plug in 10, positive times a positive
400 times 1.
is going to be a positive.
I wanted it.
Okay.
This is not his line.
There's 9 cents. It's the lesson.
This is nice.
Now let's do acceleration.
I mean, 12.
Okay. So acceleration is second derivative. So that is, so a of t is equal to 12t squared minus 72t. Okay. You can factor out a 12t. And you get t minus 6. So you have 12t equals 0, t minus 6 equals 0. So you divide by 12, you'll get 0. Add 6, you'll get 6. Okay. So now we got to figure out where, or we got to figure out signs. Okay. So in between 0 and 6, 1, 2, 3, any of those numbers. So if I pick 1, 12 times 1 is 1. 1 minus 6 is negative 5. So negative 5 times 12 is a negative number. After 6, 7. 7 times 12 is positive. 7 minus 6 is also positive. So if you multiply a positive times a positive, you're always going to get a positive. Okay? So now we have to answer the question, where do they have the same signs? Where does velocity and acceleration have the same signs? Well, it looks like from 0 to 6, both are negative, right?
Yep.
And then from 9 on, both are positive. Okay, so that's what we're going to have. Okay.
You guys want to go speed infinity?
So speed is increasing from 0 to 6.
No, it's decreasing. It's negative.
It's still increasing because they're the same. They're same sign.
They're both negative from 0 to 6.
You're still
Yeah, so what you're trying to do in your head is do this right here. You're trying to put them like right on top of each other like that and say, where do they have the same sign? Well, from 0 to 6 and then after 9.
Between 6 and 9 are different signs.
From between 6 and 9 is when they'll have different signs. Or 9 to infinity. Because velocity and acceleration have the same signs.
I think it's because the words, the curves after
It's alright. It's gonna curse you now.
Okay.
We got a graph now. Thanks.
All right.
Grass.
So yeah, so the next one, they give you a graph. It's the same thing, it's just they give you a graph. And lucky us, we just finished a section where all we had was graphs, right? Don't worry about the green dots. Don't worry about if they're not green on your paper, but they're green on mine, but don't worry about them. They don't really help us with the question, but
Inflections are when there's
yeah.
zero, right?
So first thing to do is always identify two things, what they've given you and what we need to find, okay? So that's the two things. So what have they given us and what do we need to find? So a particle moves along the x-axis so that the velocity is going from 0 to 18, okay? Given by v of t, whose graph is shown in the picture below. So the graph is what? First derivative, right? It's velocity. They're not giving us position. They're giving us velocity.
Inflections when there's zero?
That's the third derivative.
Okay?
They gave us the
That's the first thing. Okay, the inflection points are marked with green circles. It's the inflection points of the position, yeah. Okay?
Aren't inflection points supposed to be zero?
Yeah, this would be 0.
Why is it one at, like-
They gave the inflection points of the.
Yeah.
I don't know.
Because that's supposed to be zero.
Don't worry about that. Yeah, just don't worry about
It's
that.
supposed to be zero.
It's
Okay, so-
That's not where.
What are they asking us to find? Find the intervals of time when speed is decreasing. So when is speed decreasing? Have opposite signs. Opposite signs.
Oh, no, I'm going that way.
Okay? So we got to figure out where velocity and acceleration have opposite signs. Let me write this down so I don't forget.
Hey, it's right there.
So those are opposites.
Have
I'll walk this
opposite
way. Okay, I'm gonna walk this way. Screw you.
signs. Okay. So our first thing to do is figure out when does velocity have a positive, when is velocity positive, when is velocity negative. So how do I figure out where velocity is positive using this graph here? What do I look for? The y values, right? The velocity. If I want to know about velocity, I look at the y values. Good.
Oh no, wait a minute.
If I want to know about acceleration,
No, we better not have to look at the slope.
slopes.
No.
Okay? So I'm going to color code mine. Okay, so green, I'll say that velocity is positive. Light blue,
It's like, what's it, 1.2?
I'm going to say velocity is negative. Okay. Okay, so at the very beginning, at 0, is velocity positive or negative? At the very beginning, is velocity positive or negative? It's going to be green or blue. At the very beginning,
Velocity's positive.
positive, right?
Positive like 1.
And then it switches, right? The y values then switch.
Yeah. And then look.
And then it becomes positive for a little bit. And then it goes back to negative, right?
Oh man.
So now we know where velocity is positive and velocity is negative. Okay? Where now, how am I going to tell when acceleration is positive and when acceleration is negative?
When the slope is positive, when the slope is negative.
When the slope is positive and when the slope is negative, increasing and decreasing, right? So I start decreasing. When do I change to increasing?
At,
8. Okay. So in this region here, acceleration was negative. And then it increases until about 13, right?
Yeah. These guys do not know what an inflection point is. They just circled hook off. They circled whatever. And I'm like, alright, this is an inflection point now.
And then from the rest of the way out to 18, it goes back to decreasing, right?
This gives us everything we need to know.
It gives us everything we need to know. We just have to interpret it now.
Darn.
Okay? So we're looking for when V and T have opposite signs. Opposite signs. So which intervals do velocity and acceleration have opposite signs?
Like 0 to 1.
So let's see. Velocity is positive in the green, right? So we start at the green, positive, right? Acceleration is negative. So that's 1, so 0 to 1. I'm going to jot that down here. It's not my final answer part, but I'm going to jot it down so I don't forget it. Okay, and then velocity goes negative, and acceleration is still negative, right?
Yeah.
So that part I don't want. And then it switches. But we want this part, right? Because velocity is still negative here, but acceleration is positive. So from 8 to 11?
Yep. So we got 0 to 1, 8 to 11, and...
Okay, and then after 11, they're both positive, right? Acceleration and velocity are positive.
Yep.
And then when we switch over,
Whoa.
this green part we want, right?
Yep.
Because that's where velocity is positive, acceleration is negative. So what is that, from 12 to 16? Or sorry, 13 to 16. And then after 16, they're both negative, right?
Yeah.
Okay, so that's where the 3 intervals that we want. So we're going to answer the question now. Speed is decreasing from 0, 1, or 8, 11, or 13, 16. Because velocity, v of t, and acceleration have opposite or different signs. Done. Okay. Okay. Example 6, another graph. So what have they given us and what do we need to know? What are they asking us for? So what have they given us on this graph here?
Velocity.
It's velocity again, right? First derivative. They've given us first derivative, and they want us to find intervals of time when the speed is increasing. So the opposite of the last question, right? So speed is increasing when velocity and acceleration are what? Are the same sign. Okay. So I'm going to color code this again. I'm going to say green, velocity positive. Light blue, velocity negative. If it's the first derivative graph, and they're asking us about velocity, that's just the y values again, right? So when are the y values positive and when are the y values negative? Well, it starts negative, and then we go to positive. We don't cross, we keep going positive until 17, and then we switch over to negative just a little bit. Okay. Now, when is acceleration? Acceleration is slopes. So in other words, when is the slope? When am I going up the roller coaster? When am I going down the roller coaster, right? Increasing, decreasing. Okay, I'm going up the roller coaster from 0 to about 4, right?
It's going down a lot.
Going up from 0 to 4, so that's positive. So acceleration is positive. Then I'm going down, I'm decreasing until about 9, yeah? Then I'm increasing till about 12.
Yep.
And then decreasing the rest of the way. Okay. All right. So we're looking for when V of t and A of t have the same sign. Okay? Well, we start from 0 to 4, acceleration is positive. Where is velocity also positive? 1 to 4, right? 1 to 4. Okay, so let's jot that down. Okay. And then after 4, we go into acceleration is negative. But velocity is positive the whole way, right?
Yep.
So we don't have anything there. And then we're increasing, right? So that's acceleration positive, and is velocity positive? The whole time, right? So from 9 to 11. Let's see. 12, sorry, yeah. Then after 12, velocity is still positive, but acceleration is negative. That's opposite signs until we get to 17 to 18, right? 17 to 18, we have the same sign. So 3 intervals again. All right. So we say speed is increasing from 1 to 4, or 9 to 12, or 17 to 18, because, let's see, V of t and A of t, is that the bell?
Yeah. Yep.
Oh, wow.
Yes, that's.
Have the same time, sorry. Sorry, guys.
There it is. That's example 6.
I misread that because you guys are having so much fun.
All right, you're trying to.
Yeah, this was